Okay, welcome to my lecture series on theory of probability. In the last class, actually we have started with the concept of combination. Now in today's class, we will be actually dealing with some special types of combination. Like you can see, the first thing that we should discuss is the total number of combinations, that is to find the total number of combinations of n dissimilar things, taking any number of them at a time. So that is what we are going to discuss today with some examples, and there are actually two cases under this category, that is to find out the total number of combinations. Now the first case is that when all things are different. Now if all things are different, okay, then in how many ways you can make a selection of those n dissimilar things by taking all of them at a time? That is the question. Okay, that is when all the things are different in nature. Now you see, now since we have n dissimilar things in your hand, then in how many ways you can make the selection? Now the thing is that you just select the first thing. Now you can either select the first thing or reject it. If you look at the first thing, you can either select it or reject it. That means the first thing can be disposed in how many ways? In two ways. That is, either you select it or you reject it. Similarly, the second thing, if you consider the second thing is also can be disposed in again two ways, because you may select it or you may not select it, that means you may reject it. So going by this logic, if you go to the nth thing, because you have n things in your hand, the nth thing can also be disposed in how many ways? In two ways. So what I find is that I can dispose the first thing in two ways. Similarly, I can dispose the second thing again in two ways, and in this way I can dispose the nth thing in two ways, because in why two ways? Because either I may select it or I might reject it, right? Therefore, what is the total number of ways by which we can select n dissimilar things, okay, by taking all of them at a time? And that will be again by the fundamental principle of counting. So the fundamental principle of counting says that, so it will be 2 into 2 into 2, and it will be up to n times, because there are n things given to us. So it will be 2 to the power n, and which I have written in my slide. You can see the total number of combinations of n dissimilar things by taking all of them at a time is 2 to the power n. This 2 to the power n is coming because of this concept. So what we are finding is that, repeat once again, so everything can be disposed in two ways. That is, either you select that particular thing or you are not, or you don't select that particular thing. So since everything can be disposed in two ways, and since you have n things which you have to select, which are all different, therefore the total number of ways you can make this selection will be 2 to the power n by using the fundamental principle, because I need all these cases. So therefore it is the product rule of the counting, and therefore it is 2 to the power n, right? Now let's say I want to find out the total number of ways in which one or more things are taken, or rather I say that I want to find out the total number of combination where at least one of the thing is taken, Now what is the total number of ways I can get it? Now since I have obtained that 2 to the power n is the total number of ways, okay, by which we can select those n dissimilar things by taking all of them at a time. Now there includes only one case where you are actually not selecting any one of them. That means you are rejecting all those n things. That is, you are rejecting the first thing, you are rejecting the second thing, you are rejecting the third thing, you are rejecting the nth thing. That means that is the only one case where you are rejecting all the things simultaneously. So if you subtract 1 from 2 to the power n, if you subtract 1 from 2 to the power n, you will get what? You will get the number of ways of selecting at least one of the n things, right? So that's what so that's why the result is 2 to the power n minus 1, which I have written, the total number of ways in which one or more things are taken. One or more means actually at least one thing, same meaning. So that is the concept of the total number of combinations where we are selecting n things which are all different in nature, right? Now this can be demonstrated by two very simple examples. I mean the examples which are related to these which I have just now told you. If you look at the first example, see, the first example says that there are 5 questions in a question paper, right? There are 5 questions in a question paper, and the question is, in how many ways can a boy solve one or more question, right? So there are 5 questions in a question paper, right? And in how many ways can a boy solve one? So that means in how many ways can a boy solve at least one of the question, right? Now since there are 5 questions, so first question 1. So question 1. Now the first question, question 1, the boy can either answer or don't answer. I mean the boy can either answer first question or do not answer the first question. So he can dispose the first question in how many ways? In 2 ways. Either he answers it or he doesn't answer it. Similarly for question 2 also, he can either answer it or do not answer it. That is, he can dispose the second question also in 2 ways. Either he answers the question or he doesn't answer the question. In this same logic, he can dispose question 3 again in 2 ways. Similarly, he can dispose the question 4 in again 2 ways, and the question 5 also again in 2 ways, right? So what we find is that he can dispose these 5 questions in 2 to the power 5 ways. So the total number of ways that he can answer the questions, there are 5 questions given here in the question paper, will be 2 into 2 into 2 into 2 into 2, which is 2 to the power 5. But that is not what I have been asked. I have been asked to find out that in how many ways can a boy solve one or more question. That means in how many ways can he solve at least one question. Now 2 to the power 5 gives me the total number of combinations of answering this 5 questions by that boy. But this will include only one case where he does not answer any one of these 5 questions, isn't it? Like we told in the previous case also, that there is only one case where he does not answer question 1 and question 2 and question 3 and question 4 and question 5. So he does not answer any one of the 5 questions simultaneously. That's only one case. So therefore the total number of ways, so the total number of ways that he answers at least one question, at least and one or more questions are same, at least one questions will be equal to 2 to the power 5 minus 1. So I have to subtract that only one case where he is not answering any of the 5 questions, and if I subtract that particular case, then I will be left with those cases where he answers at least one of the question which is asked. So you can see it is exactly the direct application of the total number of combinations, okay, where all things are dissimilar in nature. Another question will make things even clear. Now if you go to the next problem in the slide, you see I have asked this question: from 4 mangoes, 3 oranges and 2 pineapples, okay, how many selections of fruits can be made taking at least one of each kind? So taking at least one of each kind. Okay, so keep that in mind. So you have to make a selection in such a way that at least one of each kind must be there in the selection. Now again, this will be answered easily by using this principle which I have just now taught. Okay, now first you tell me how many mangoes are there. There are 4 mangoes, right? There are 4 mangoes. There are how many oranges? There are 3 oranges. There are 3 oranges. And there are how many pineapples? There are 2 pineapples. Okay, there are 2 pineapples. Now you see, first we come to the mangoes, right? Now this 4 mangoes that you have, now in how many ways can you select these 4 mangoes? You can select those 4 mangoes in 2 to the power 4 ways, because either you may select the first mango or do not select it, because there are 4 distinct mangoes. So either you select the first mango or don't select it. Same, so 2 ways you can dispose it, the first mango. Same thing, the second mango can be disposed in 2 ways, third mango can be disposed in 2 ways, fourth mango can be disposed in 2 ways. So therefore the total number of ways of disposing or making a selection of 4 mangoes will be 2 to the power 4. But since I have asked you to find out that in the selection that you are making, okay, there should be at least one of each kind, that means there should be at least one mango. So you have to subtract that only one case where you are not selecting any of the 4 mangoes, and so it is 2 to the power 4 minus 1. So 2 to the power 4 minus 1 gives you the total number of ways where you are selecting at least one mango. So this gives you number of ways of selecting at least one mango, number of ways of selecting at least one mango, okay, at least one mango. So number of ways of selecting at least one mango. By same logic, since we have 3 oranges, again you can see you can make a selection of 3 oranges in 2 to the power 3 ways. But again you see, out of those 2 to the power 3 ways, there is only one way you are not selecting any of the 3 oranges. So since you want to have at least one orange in your selection, so therefore I have to subtract that particular case where I am not selecting any of the 3 oranges. So my total number of selection where I will have at least one orange will be 2 to the power 3 minus 1. So this will give me number of ways of selecting at least one orange, number of ways of selecting at least one orange. And by same logic, for the 2 pineapples, okay, we get by the same logic, that is 2 to the power 2 minus 1. Why? Because there are 2 pineapples, so you can dispose those 2 pineapples, or you can select those 2 pineapples in 2 to the power 2 ways. Okay, that is either you can select the first pineapple or don't do it. So both the pineapples can be disposed in 2 ways or 2 to the power 2. But there is only one way where you are not selecting any of the 2 pineapples. So that you have to subtract. So 2 to the power 2 minus 1 gives you number of ways of selecting at least one pineapple. So what I've got 2 to the power 4 minus 1 is the number of ways of selecting at least one mango. 2 to the power 3 minus 1 is the number of ways of selecting at least one orange, and I've got the number of ways of selecting at least one pineapple. And my question asks is, how many selections of fruits can I make taking at least one of each kind? Therefore, the total number of such selections that I can do where I'll have at least one of each kind, that means I'll have at least one mango, I'll have at least one orange, and I'll have at least one pineapple, will be again by the fundamental principle of counting, and that will be equal to 2 to the power 4 minus 1, because for every 2 to the power 4 minus 1 ways of selecting at least one mango, there are 2 to the power 3 minus 1 ways of selecting at least one orange, and 2 to the power 2 minus 1 ways of selecting a pineapple. So therefore the product rule being applied, and this gives me the total number of selections that we can make such that at least one of each kind is included in that particular selection. Okay, so that's all for today's class. In the next class we will discuss some more important cases of this total number of combinations possible. Thank you.